This is section 5.4, the fundamental theorem of calculus. Now when we look at this, the word fundamental is in the title. So this is probably one of the most important sections in all of Calculus 1. So this is very, very important. This will allow us to find the area under a curve, and we're going to use the definite integral. So remember, the definite integral is defined as the limit of the Riemann sums. So we take the limit of n approaches infinity of the intervals from 1 to infinity of the function at x sub I delta x. So the fundamental theorem of calculus connects definite integrals with indefinite integrals and gives an alternative method for evaluating definite integrals. Okay, so let's go through it. The fundamental theorem of calculus, FTOC, that's for short. Part 1 says, if the function is continuous on the interval from a to b, then f of x has an antiderivative on that interval from a to b. Part 2, if f of x is continuous on that interval from a to b, and the function has an antiderivative from a to b, then we can do this. The integration from a to b of f of x dx equals the antiderivative taken on the intervals from a to b. So what do? We find the antiderivative, or we integrate. Then we're going to plug in the upper limit into that function, and then we're going to subtract the second function, which is the antiderivative at the lower limit. Using the fundamental theorem of calculus 2 is contingent on being able to actually find the antiderivative. Okay, so let's go ahead and look at example number 1, which says, evaluate the definite integral using the fundamental theorem of calculus. So we're going to integrate from 0 to 5 x squared dx. So if I use the fundamental theorem of calculus, first of all, I need to take the integral. Okay, I see that my function is f of x equaling x squared. Okay, so the rule says that I take the power, I add 1 to it, and I divide it by that power plus 1. So this becomes x cubed over 3, or we can say 1/3 x cubed. Okay, so I did the integral. So that's step number 1. Step number 2. Now we're going to analyze the antiderivative, which is what we found, 1/3 x cubed, at the upper and lower limits. So remember, the upper limit is b and the lower limit is a. Okay? So what I'm going to do is I'm going to look at b first. I'm going to plug in what b equals, which is 5, and plug it into the formula. So I get 1/3 times 5 cubed. Which is 125. So what I'm going to do is take 125 divided by 3. And I'm going to leave this because I might get the same value, something over 3 for part A. So I'm going to leave it just for now. So you do the same thing with the lower limit, which is 0. So I plug it in. 1/3 times 0 cubed, which equals 0. And now I subtract. So I'm subtracting the antiderivative at b minus the antiderivative at a. So what does this look like? This looks like 125 over 3 minus 0, which equals 125 over 3. So now I just found the area under x squared going from 0 to 5. That's what it did. Okay? So we're going to do the same process again for b. B is taking the integration from 1 to 3 of x cubed plus 4x. So the first thing we have to do is take the antiderivative. I should say not take, but find. We have to find the antiderivative. Okay, So again, I have x cubed. So this is 3 plus 1 over 3 plus 1 plus 4x. So 4 times x to the first plus 1 over 1 plus 1. So when I do this, I get 1/4 x to the fourth plus, now this is going to become 2 in the denominator there. So 4 divided by 2 is 2. So this is 2x squared. So that is the antiderivative. Okay, so my next step is we're going to find the antiderivative at B and the antiderivative at A. Okay, so let's go ahead and do that. B, by the way, was 3 and A is 1. Okay, so I'm going to do 1/4. By the way, I'm working on B. So 1/4 times 3 to the 4th power plus 2 times 3 squared. Okay? Okay, 3 to the 4th power is 81. And this is going to be over 4 plus 9 is 3 squared times 2, which is 18. Okay? I'm going to find a common denominator, and the common denominator is going to be 4. So 18 times 4 will give me 72. Now when I add these up, I get 153 over 4. So now I'm going to find f at A. So same process, but this time around I'm plugging in 1. So I get 1/4, 1 to the 4th, plus 2 times 1 squared. Okay, so this becomes 1/4 plus 2 times 1, which is 2. Again, finding a common denominator. 4 times 2 is 8. This becomes 9/4. Okay, my last step is to subtract the antiderivative at B minus antiderivative at A. So this is 153 over 4 minus 9 over 4. And when we do the math there, we get 144 over 4, which reduces down to 36. So this is the area under the curve of x cubed plus 4x going from 1 to 3. Okay. Example 2, evaluate the definite integral using the fundamental theorem of calculus. Okay, so remember we can use the rules and take the constant and pull this out. So I'm taking 2 times integration from 0 to pi over 3 of cosine x dx. Okay, so if you remember, one, we have to find the antiderivative, right? So basically the antiderivative of cosine, if you remember correctly, is sine. So I get 2 times the antiderivative of cosine, which is sine x. And remember, I'm taking that on the interval from 0 to pi over 3. Part 2. Find f at b, which is the upper limit, minus f at a, which is the lower limit. So f at b, I'm going to work on that first. So 2 times sine of pi over 3. Pi over 3 was 60 degrees. So it's 2 times radical 3 over 2. You'll see those 2's cancel, and I get just radical 3. Okay, now I have to find the other one. So 2 times sine at 0. And when I get that, I get 2 times sine at 0 is 0, so this becomes 0. So now my third step is to subtract. So radical 3 minus 0 is radical 3. Okay, let's do B. Now, remember, when you're integrating, if I have something that is a quotient, that's no good unless it matches one of the rules, which this does not. It doesn't match any of the inverse functions. So, what we're going to do is we're going to split this up because I'm dividing by a monomial. Whenever I'm dividing by a monomial, I can do this, okay? So basically, I've got to simplify this. So this is x to the 1/2 minus, and then minus 5 x to the negative 2, okay? So when I do this, I get x to the negative 3/2 minus 5x to the negative 2. So what I'm actually integrating is from 1 to 4, x to the negative 3/2 minus 5x to the negative 2 dx. Okay, so you have to do that step first or else you're not going to be able to take the integral of it. All right, so now we need the antiderivative. So this is step number 1. Okay, so I get x to the negative 3/2 plus 1 over negative 3/2 plus 1. And then minus 5, the 5 I can kick out, and I do x to the negative 2 plus 1 over negative 2 plus 1. So I'm going to have to simplify this out. Okay, so plus 1 is 2 over 2. I get x to the negative 1/2 over negative 1/2. So this becomes negative 2 x to the negative 1/2. And then minus is going to be a positive 5 because of this. And then I get x to the negative 1 power. And that is my antiderivative. Okay, I'm going to write this out because I have to plug in stuff. So this is going to look like this. Negative 2 over the square root of x plus 5 over x. And I'm plugging in the values from 1 to 4. So step 2, find f at b minus f at a. So let's go after f at b first. So I plug in 4. So negative 2 over the square root of 4 plus 5 over 4. So this becomes negative 2 over 2 plus 5/4. Doing a little bit more simplification, I get negative 2 over 2 is negative 1. But because I have to find a common denominator, I'm going to write it up as negative 4 over 4 plus 5/4, which equals 1/4. Okay, that's f at b. Now, f at a. Same thing, plugging and chugging. Negative 2 over the square root of 1 plus 5 over 1. Okay, you luck out on this because you're going to get a whole number. You're going to get negative 2 plus 5, which equals 3. Okay, but my last step, number 3, is to take f at b minus f at a. So I have 1/4 minus 3, again, common denominator of 4. And this becomes 13/4. And I made a small mistake, guys, because I forgot to subtract. So let me just fix that really quick. So we're just fixing the last step, okay? Because I accidentally added instead of subtracted. So it's 1/4, right? 1/4 minus b, which is 3. So that's going to be 12 over 4. And this is going to give me a negative 11 over 4. Sorry about that. So please fix that really quick. And then I'm going to stop the video and make a part 2.